Okay, I'll just get you guys introduced so you guys can start on time.
Sounds good.
So this is the data center, it's an Edge modular hardware system session. And everybody has been hearing about applications, and we all know that the modern applications are built on microservices. And I think the fundamental thing is really about trying to get better cost of ownership and operational efficiency if you can modularize and get these workloads and services on common hardware, common systems. I think with that context, I wanted to introduce Shawn, Dirk, and Vincent to kind of basically go through this modular system session. Thank you.
Good, thank you. So, I'm Dirk Blevins. I'm a senior platform architect and principal engineer from Intel Corporation. I'll let the other guys introduce themselves.
I am Shawn Dube, senior distinguished engineer and focused on platform pathfinding for Dell, Dell Technologies.
Good morning. My name is Vincent Nguyen. I'm represent HPE here. I'm a senior distinguished technologist within HPE Compute Business Unit, and my primary responsibility kind of look forward in terms of what the architecture and the portfolio look like for our Poline family.
So we're here today to talk with you all a little bit about some of the elements that we've been doing in DC-MHS and looking at the need that we've been being requested for around the possibility of doing similar substructures for and building blocks for the Edge solutions. We're looking at, is this a possibility, does this make sense, and how those things can materialize into better efficiencies, essentially, for Edge solutions. Now, just watched the end of the last presentation. Obviously, the Open Edge has been quite successful within the OCP, but that's a type of Edge system, and there's a lot of Edge systems, and we'll talk about those as we move through there and talk about how our vision, at least, would be for the possibility of having Edge building blocks that you can build multiple types of systems, up to and possibly even including this. As well, we want to make this an interactive session, guys, so, and folks, and feel free if there's questions that you want to ask even during the session, we're willing to take those, right? Yes.
Yeah, just raise your hand or just blurt something out, we'll cover it.
Sounds good, thanks. So, as we start this, we're going to go through some of this conversation. Basically, the agenda today is going to be the who, what, when, where, how, and how kind of thing. We're going to talk about why Edge modular standards and why they may make sense. We're going to talk about what an Edge-MHS might be. Now, keep in mind, we're in our infancy of exploring this. We've been looking at it for some time, but we still believe there's a lot of work to be done to get through the challenges that we're going to talk about today that we're seeing. In addition, we're going to talk about when we might be able to expect some of these things to become available. And then we're going to talk about where they would potentially be developed and how they would be developed, at least our proposal for that. And then we're also going to give you an idea where you can contribute and where you can be able to participate in some of these particular work streams and work efforts that we're doing. You have anything you all want to add? So, the first statement is, why? Why do we care? Well, the reality is that as we look at workloads that are coming about, regardless of what they are, there's been a lot of talk. This year's theme of being, a lot of AI conversations. The reality is that these workloads are going to be so intensive from a bandwidth and latency perspective. The applications are going to have to move to the edge. Even if you look at a lot of the examples that's shown on the left-hand side, the latency aspects of being able to drive those applications are absolutely critical. And, if you've got a robot arm that's putting together a vehicle, and you can't respond quickly enough, then that's a problem. So we're seeing a big push due to bandwidth and latency issues that's driving these solutions back towards the edge. Now, that doesn't mean that the cloud is gone, It just means that you're moving the cloud-like principles more closely and co-located with the edge. Then when you do that, you start having to worry about security, connectivity, and these other functions that has to come about. Fleet management, the ability to deploy and manage solutions, These are all challenges. So, as we start to look at it, why do we care? Well, from a fiscal standpoint, the edge is a big market. See from the data shown here that it's expected to grow at a 32.3% CAGR and be a greater than $155 billion market by 2030. That is a very sizable market, and we're seeing those that push being requested all the time from a lot of our different customers and a lot of our different applications. So this is a big market. In addition to that, AI is a piece of the market that, quite honestly, is unexplored yet. It's the new frontier, and I do believe, we all believe, it's going to be a big deal. It's going to be a big market as well, and it's going to be a sizable reason for why these applications are going to have to move to the edge. So it's a big market. The challenges are there. The ability to be able to move the workloads are going to be required. And then after we start to do it, we're going to let Vincent take us through some of the technical challenges that we may face.
Yeah, so while we're defining the DC-MHS 1.0 specification, focus more on data center, and and then we look at it, and then we determine there are definitely gaps, that there's opportunity for us to define that optimize for the edge, where the market segment is growing significantly, right? So if you look at it from the specs perspective today, most of the specs, like I say, can address all the way to the near edge. However, the mid edge and the far edge, where the environment and also some of the deployment use case are different in terms of chassis depth, cabling management, right? So from all those challenges, we realize that there are opportunity for us to create a new ecosystem that really optimize for edge, not just for telco, but for retail, for manufacturing, and for healthcare and all that stuff. So there's a lot of opportunity, and we believe that opportunity is here, and we're going to start looking at it and how to provide a specification to create an ecosystem that really optimize to address the edge from both environment as well as the chassis depth, the cabinet that need to go in.
Yeah, and if I can add to that, so on the far right of this diagram, the near edge, we have DC-MHS that very well covers a good portion of the near edge, but there's still the opportunity to go smaller, and then especially as you move further to the left in this diagram, the mid edge and the far edge, that's where there is clearly a need for additional standards for standardizing the HPM, the host processor module. The green box here does show kind of the limit of where we see. There is a point where we don't think that an Edge-MHS standard should go further to even smaller systems. So the extreme maybe on this drawing is a Raspberry Pi at the far left. That's not an area that we want to approach, but we want to discuss that. All right. So finishing out some of the challenges. So the install base that we have for Edge is quite broad. In the data center, we do have variety. We do have different size racks. However, in Edge, it is much worse. So we have racks that are extremely short depth. We have environmental situations that are quite varied. Cable routing, well, at least in the data center, if you're using 19-inch rack, probably your I/O cables are going to the rear. If you're using open rack, I/O cables are going to the front. In the Edge, it's a mix. There are multiple right answers. Power's more varied. It's not high voltage AC or high voltage DC coming in. We have a variety, negative 48, 12 volts. Then we get into the different types of platforms. There are quite a variety of different platforms. In this diagram, we're showing racks. Well, that's not necessarily where all Edge systems go. We have classic tower systems, but now we have Edge systems that are pedestal or going to corners, to small crannies. Vincent, you want to add you want to add anything to that?
No, I think you hit it. So.
Okay, so we have a lot of variety that we're having to deal with. All right, so getting into what is a pathway forward? So first off, this is a slide that describes the initial goals with DC-MHS. We have a situation today, and actually this was 2 years ago when this slide was first put together. Lots of a wide variety of silicon, different CPUs, new classes of processing elements, XPUs, APUs, and every platform producer having to produce custom motherboards for every situation and going into their variety of platforms. This was inefficient. DC-MHS aims to solve this, or is solving it, in that we have standard motherboard form factors, host processor modules. We define the elements for going in and out of the HPM. We've defined a set of power supplies that cover a broad portion of the data center market. And the idea is to improve the efficiency from CPU to building the circuit board underneath the CPU, streamlining that operation that allows for the silicon providers to innovate, to go fast, that allows, and then using the HPM model as a form factor that drops in, it allows the platform producers to innovate, focus on what they do best, and to go fast, adopting the innovation from the silicon providers. This is what we want to bring to the edge.
Now, with that said, I'm going to add to that just a little bit. If you walk out on that show floor and walk around, you'll see dozens of systems exemplifying exactly what Shawn said. There's a bunch of DC-MHS built systems that are built with Intel processors. They're built with AMD processors. They're built with Ampere. They're built with NVIDIA. They're all out there on that show floor right now, showcasing exactly what Shawn was talking about, where you could take the different building blocks and place them together quickly.
Yeah, so a collection of the DC-MHS members have been discussing, exploring, will this be successful? Is there a chance of us having common goals, common scope for what we want to do, defining a set of HPMs and other technologies for the edge? We initially have positive results, at least in general ideas, and so we're proposing, next slide, we're proposing setting up a group to continue that's broader than DC-MHS today, but a group to explore, do we have a common set of goals and objectives that we can make this happen? We're proposing to structure this under the DC-MHS sub-project within servers. When we set up DC-MHS initially, we knew that we had a very broad vision and long-term vision, and we set up our structure internally that easily allows for new work streams to independently operate as well as collaborate together. Joining DC-MHS does not obligate you to participate on all work streams. We can set up a work stream that's dedicated to the edge solutions. So this diagram here shows an example of it. And then as we get into how are the different technologies working together, I hand back to Vincent.
Yeah, so basically, as you can see, this is typical, some of the use case that we believe is at the edge. And you can see it go beyond telco, right? It's going from manufacturing, retail, all the way up to office, healthcare, building, and all that. And typically, you can see the requirement are vary even within the edge. So our goal is somehow create a component ecosystem that can be leveraged across different market segments that you see here, right? From IoT, it's just a device itself, right? It's basically for data acquisition at the manufacturing floor, or it can be for smart city, right? And then, as Dirk mentioned, AI is growing, so there are a lot of inference workload that definitely need to run at the edge, right? So we need to basically optimize the server can quickly deploy within the rack, and can easily manage remotely, and also can even sit in the corner store of a retail store, right? So all that AIs play an important role, and then back to the manufacturer, robotic is very important, right? So how you gonna create a robotic system that control those machines, right? And then for healthcare, I mentioned AR, VR, and then more the last piece I would like to talk about is like Open RAN. There are definitely a need for telco, right? For vRAN, for network virtual function system, right? All those are definitely a requirement for the edge in terms of typical use case. So to create this, as you can see, Shawn mentioned, there are different requirements. How we're going to optimize this? For one thing we acknowledge is the HBM today is not optimized for the edge. The far
ones
edge,
defined in DCS.
Yep, the current defined in DCSM, right? So we want to take this opportunity to optimize the HBM to more single socket focus, and the HBM depth to be short that can fit in even down to 300 millimeter, right? And then at the same time, we also recognize the DC-SCM module is co-planar today. It definitely kind of go against the chassis depth design principle. So one of the things that we're gonna not just looking at the HBM, but we also look at the component eco of DC-SCM that we can vertically plug into the HBM rather than co-planar. That will enable us sort the chassis depth further. And then, you know, we also need to create a component ecosystem for fan, right? Reversible airflow, right? And the stuff that form factor optimized for fun cabling. So all these is the possibility. Definitely we're gonna talk about it. We're gonna create a specification to define this ecosystem going forward.
Yeah, a couple things to add to that. So with the challenge that we have with DC-SCM today, and we want to solve this as part of Edge-MHS, there are other ideas that we have within the data center that we see benefit with the same exact solution. So this is where we see a benefit of having this as part of DC-MHS, that we have an ecosystem of intercompatible modules that can be used regardless of what the end application is, edge versus data center versus other applications. There was a question before we started on clocking. So this is where we get into yet another challenge with edge applications, in that there is a wide variety of different types of I/O, and clocking synchronization is a key example of that. And that's where we think that we need to do something a bit more of having flexibility of different classes of I/O, of how they connect in with the HBM, how that they can allow for a single edge application to go or edge platform go after different applications, whether it is telco or data acquisition or processing that's not related to telco, and this is where that modularity comes in. So as we move forward, we think we've got a common set of goals, at least as general sizing of HPMs, depths of chassis, and so I guess let's go on to the next slide. This is where we're wanting to expand the effort to understand what other objectives others would have with this sort of thing, and bring this in so that we can really build an ecosystem of modular parts within the system that allows us to all use them to accelerate our velocity, but also to still enable innovation.
So with that said, you know, as Shawn mentioned, we're looking at the exploratory group that we formed. We also are going to start to try to work towards bringing together these common elements that Shawn talked about into a specification. In so doing that, the target would be to try to have some initial specifications done by this time next year, that people can review. Obviously, the methodology that the DC-MHS has followed in the past is we dropped intermittent releases, a 0.3, a 0.5, a 0.7 that have particular meanings, moving all the way up to a 1.0. So be looking for these particular things.
And just to note, the 0.7 within DC-MHS nomenclature means that it is something that you can start designing to, but it is not at all final. Changes are going to happen, improvements are going to be made, but it at least gives a reference point to start designs to be ready when the spec hits 0.9 or 1.0.
So with that said, to get involved, first, if you're interested in participating, we do have our DC-MHS at opencompute.org mailing list that comes to all of us, the master blasters, we like to call it. We will see that and look at what input you can provide. Obviously, there's a lot of information already on the DC-MHS and some of the stuff that we've done from a connectorization standpoint to a pile of specifications that we already have for these building blocks that we're talking about. I encourage folks in the Edge community that are interested in Edge to start to look at these things and understand where the convergence of these building blocks could start to take place, where we can start to see opportunities for, another question was asked, how could the open edge play with these specifications? Well, the ideal situation would be that we worked collaboratively to understand the requirements. It's something that the open edge could consume in a future revision. Now, don't know that will happen, but that's the ideal situation, that we could see that the building blocks are the same regardless of what you're doing. We're not defining the systems, we're defining the building blocks. Anything else you guys want to add as we close?
I think it's about volume scale, right? If telco want to leverage the ecosystem of DC-MHS, the volume, in my opinion, will be larger than typical telco only. So I think definitely there's a volume cost benefit of leverage across the initiative, basically. That's the point I want to make.
Yeah, very much agree with that. So, questions, discussion, tomatoes, anything.
No
Step up
tomatoes.
to the mic.
No potatoes, for sure.
Can you hear me? Hey, good morning, everyone. I'm actually from Fastcon. Just got a question. I think you guys brought a very good topic, very hot topic. So I came from a telco background. I think the idea is that to bring the DC-MHS across the board, as you all mentioned, right? So the question is, I know this OCP or the DC-MHS started from the IT world, actually, kind of, right? Any plans to get those telco guys involved as well? So that might be very powerful. That's my question or suggestion.
We're here. We're throwing out the invitation. So, yeah, approach us from the telco world.
Yeah, especially.
But within each of our companies, we also have our groups that focus on telco. Yep. So there's both the internal approach as well as the collaboration that we have here.
Yeah, and I think to further that a little bit is that we're always interested in taking on new members that can help and contribute. I mean, and we've got new members as of last week wanting to possibly join. So it's something that's there. Right now we just haven't had any of the telcos approach us, frankly.
Yep, just probably maybe just have to go out to recruit those guys. I think especially when those global tier one carriers like AT&T, Verizon, T-Mobile, or like extend to Europe or Asia, right? So those guys.
I think it'd be an interesting conversation to have.
Yep. Thank you.
Any other questions? Thank you for the question. All right. Well, if there's no other questions, then I think we will end the session a couple minutes early. Thank you very much.
Thank you all.
Thank you. Bye-bye.